All right, welcome back to the NY DIY Mechanical Garage. In this portion of the video series, we are replacing the clutch, flywheel, and doing a rear main seal while we're at it because we're in there. So, as you can see, the torque tube has been taken out, okay, along with the gearbox and rear diff. The rear diff has to be sent out to a rear differential place. I'll let you know where I bring it because there could be some deals to be made and all that good stuff. So hopefully I can get the best price. I'm putting a set of 410s in that rear diff for this guy. So we're gonna do the rear clutch. We're gonna do the clutch assembly on this LT1 C7, the Sinister C7 track weapon here. So what we're gonna do first is, looks like I've been doing some surveying here. Looks like we're gonna have to drop the cradle a little bit just to give me a little bit more room to take the bell housing out. By looking in the vent holes here, it looks like the clutch was replaced at one point because it really looks brand spanking new. The customer wants to do what I did on the C5 Z06. I did an aluminum flywheel, but I did a LS7 aluminum flywheel. So the LS2, 3, and 7 use the same flywheel, and I used a LS7 clutch assembly in my C5. Now, my C5 mainly is stock with a tune and some bolt-ons, but it was a world of a difference switching to an aluminum flywheel because it revs that much faster. It's crazy. I dropped like 20 some odd pounds of rotating mass off my C5. So in this case, this clutch assembly is very heavy because it's all steel, and imagine the not really much horsepower gains, but throttle response, especially when you throttle bleep down through the gears at a road course, it's going to make a big difference. Supposedly, this car has to be tuned for that light flywheel. The car's going to get tuned anyway because we're doing a MSD intake manifold, an actual intake manifold itself. So in order to get big gains to take advantage of that intake manifold, you're really supposed to get a tune. So anyway, that's on a separate video. Let's get started on removing the clutch. So up there, you can see there's bolts all through there. Maybe you may not be able to see them, but there's one. Looks like there's two right there. 3, 4, what else? 5, 6, 7. So take these out and see how far we can get by taking the bell housing out. I may have to drop it, like I said, the whole cradle down a little bit to get this bell housing to pop out to get to the clutch assembly. So excuse the heat noise. It is freezing in my garage, so I have to have some sort of heat going on. But I just want to point something out, craftsmanship. So, like I said, someone else was in this Corvette before me. It is what it is, that's fine. I'm not Monday night quarterbacking anybody, but I am going to point out some bad craftsmanship. I get things that are a pain in the ass at times, and it sucks like, oh, I don't need to put that bolt in. It's worthless. It's not there for a purpose. You know, if engineers design something, a majority, I'm not saying all the time, but a majority of the time, it's there for a reason. In the back of the engine, there's a wiring harness, plastic a casing that holds the rear wire harness, goes from one side of the engine to the other, and my freaking light's not helping. But if you look right over here, if you look right up there, there's a bolt right there, okay? Look at this. The one back there is actually missing. I don't know if you can see it. Let's try this. Come on, see that? Look at that. See that bolt missing up there? No one ever put it in. And it's kind of annoying because, you know, I try to do good craftsmanship. I try to put things back together looking like it's from the factory. And when you see stuff like this, it just goes to show you that there are a few hacks out there, and it ain't right. Given, you know, myself and other good mechanics, or I want to call them technicians actually, a bad name. It stinks. So I just want to point that out. Shame on whoever put this back together, forgetting the hardware. So make sure you put things back together the way you found them, folks, just for safety and just quality of craftsmanship. You know, let's just try to keep this field alive with good craftsmanship. So I just wanted to point that out. All right, back to work. All right, We got the bell housing out right here. Once all the bolts came out, like I said, there is one up top. 1, 2, 3, 4, 5, 6, 7 bolts. Once that out, it actually came out really, really good. Didn't come out as bad as I thought it would come out. But here's the clutch. Here's the clutch right here. So I'm assuming we're gonna take out these bolts. 1, 2, 3, 4, 5, 6. These 6 bolts and the clutch should come right out. Look, it's made in Germany. Then this whole clutch assembly should come out, and then we're gonna go from there. So just hang 10. We'll come right back. Okay, the clutch is out now. The whole clutch assembly. So, again, when I removed that bell housing, it was the 6 bolts that the clutch housing, the clutch pressure plate assembly went on. So just slowly remove them piece by piece. The clutch plate assembly, what the hell is it? There it is. The clutch plate assembly will come off. And look at this, pretty cool, man. Twin disc setup. This clutch is brand new. Someone replaced this clutch. This thing is brand spanking new. Pretty cool. But twin disc, that's pretty neat. Z51 package car, so I guess it came with this. I believe the customer got a Z06 clutch, so we're dealing with that right now. That we're gonna put in there. But here's a clutch assembly, or clutch plate pressure plate assembly, and it is those 6 bolts. 1, 2, 3, 4, 5, 6. Take those out piece by piece, little bit by little bit, and this whole assembly should just pop right off, leaving the flywheel assembly, which is right here. Now this is pretty cool. I guess this is for dampening. It's pretty neat. It was like this before I took it off. The whole clutch plate pressure assembly went back and forth like, wow. So I'm assuming it's probably for dampening, but this is brand spanking new. Someone just replaced this because there's actually machining lines in there. You can hear them. But we're gonna out with the old, and then with this K-Tech flywheel. This thing weighs a ton. This thing is awesome. I can literally pick this up with one hand, throw it around, and not have a problem. This thing, oh my God, you can actually hear it. This thing weighs a ton. It's ridiculous. This weighs nothing. So throttle response with this thing is going to be sick nasty. It's going to be awesome. So really, really stoked for this customer. I put a Fidenza flywheel in the C5 Z06, and when I got it, I did a YouTube short. A majority of all these Phillips heads with nuts, 10 millimeter nuts in the back of it, they were all loose. So what I did was I took them all apart and I Loctited them all, just to make sure. And for future reference, do that with every single one that you buy. Even from the manufacturer, just do yourself a favor. If you buy an aluminum flywheel with a steel plate, replacement steel plate, just do yourself a favor, loosen them up, put Loctite on them, just so they don't come off. That's the last thing you want, is one of those suckers coming off there in a throttle bleep. And here's our upgraded GM clutch. I think it's the Z06 clutch. I think the Z06 a triple plate, so we'll take that out and take a look at it. So next, what we're going to do is, while it's out, we are going to, oh, my headlight died. Ah, man. We're going to replace, you can probably still see it, we're going to replace the rear main seal, and we're also going to replace the pilot bearing. He ordered them brand new from GM, GMPartsDirect.com or something like that. We're not sponsored. That's where he got his parts from. But looking in the back here, before my light died, everything for this 70,000 miles in this thing, everything is dry. But we're going to replace the rear main seal just as a precaution. So, just to give you a heads up, so when you put these rear main seals in, okay, even a pilot bearing, there's a little bit of a recess, okay, that the pilot bearing sits in, even a rear main seal, because you don't want to drive them in too much. Because you drive them in too much, you can have a leak. Or if you drive the pilot bearing in too much, it may not work very well. So what you could do is get yourself a vernier caliper, okay, or some type of depth gauge, and literally use this end to find out how deep the pilot bearing is and how deep the rear main seal is into its recessed machined hole, I should say. And that will give you your depth. So just some future advice, because you don't want to drive a seal in too much and you don't want to put a pilot bearing in too much. There could be a machine lip in there, so I can whack this thing in there and it may just seat into it and not go any further, but you don't know, and I don't want to find out. So I'm going to do a depth, see how far it is in there, along with the rear main seal. The rear main seal is dry, and this thing I'm going to replace anyway, preventative, because I don't want to go through this whole ordeal again and find out we have a leak. So stay tuned. We're going to be putting the, after I do the rear main seal replacement and the pilot bearing replacement, we're going to be putting the aluminum flywheel on there. So just stay tuned. All right, everybody. I had to pause this project for a few days because I had to order some parts. So I totally forgot that the flywheel bolts are stretch bolts, and you cannot reuse these bolts because they are torque to yield. It's like 11, 22, then 45 degrees. So the torque to yield bolts are stretch bolts. You can only use them once, and that's it. I had them in there at one point, had them all torqued in, but I totally realized that they're stretch bolts. So shame on me. So what I did was went on to summitracing.com. I'm not sponsored by them, even though you see a sticker from them. I went on to summitracing.com and got product number from ARP 2342801. They're a 12-point bolt, specifically for flywheels. If you want to grab a quick snapshot of this, pretty much install them. Torque them at 85 foot-pounds. Comes with the grease and everything, as you can see. The grease goes under the head of the bolts and then Loctite on the threads. So grease under the bolts, so it's you don't get any marring, and it's a smooth transition when it torques, and then you have the Loctite and lock the threads. So that's what I'm going to do right now. I'm going to cover this up with grease, then Loctite. Put the bolts in the car, torque them to 85 foot-pounds, and then put the pressure plate. All right, everybody. Welcome back. It's been a few days because I had to take a little bit of a break from this thing. Ran into a little bit of an issue. The issue I had was that when tightening up the K-Tech flywheel against the crankshaft, all right, torquing everything up, I had an issue with the socket fitting in the bore. Okay, now if I use the stock stretch bolts, okay, and if I use these, went in, I can get a socket on there, not a problem, because you can see the head. It's smaller than the actual bore that's machined in the flywheel. Issue I ran into is that I want to use these the ARP hardware. Problem was that when I put these in there, the socket wouldn't fit in there. So these machined bores, as you can see right here, they are exactly 1 inch. I measured them with my vernier caliper. I need something definitely smaller than 1 inch to get in here in order to torque these bolts down. Now I can use stretch bolts, but you know, since I'm doing all this work, I might as well just put good hardware in here. So since the ARP bolts I'm using are 12-point, I had to shop through sockets and actually borrow a socket from my friend. This is a older Snap-on 3/4 inch socket, 12-point, and the outside diameter of the socket was like I think it was 0.992, which will fit right in the bore, as you can see. Fits right in there. So future advice: if you want to get a K-Tech flywheel, make sure you get a thin-walled socket. Actually, if you want to use a K-Tech flywheel and use ARP 12-point hardware, you got to use a thin-wall 12-point socket. So now this goes right in. Socket fits right in there. I can torque it up without a problem. So anyway, that's the hold up that that held me back for a few days. Now I'm gonna put this on, torque these up to 85 foot-pounds, and that's it. So. And then hang tight for the next section of this clutch install. Okay, now that we got our flywheel torqued up to 85 foot-pounds with the ARP 12-point hardware, I put the twin disc GM factory twin disc clutch and bolted it up with the bolts, factory bolts, between 35 and 40 foot-pounds for the K-Tech built aluminum flywheel. I actually had an old input shaft from my C5. It's a little bent, more towards the bearing side, but I use this for my clutch alignment tool, and I gotta tell you, works perfect. Look at that, perfect. So, yeah, so everything's lined up, ready to go, and that's that. So all it's gotta do is put the bell housing on, and then fasten it up, and that's that. So this is the clutch install section of this build. Just still continue to watch. All right, thank you.